In this example, I'm going to show some concepts, illustrate how to define an enum. This is an important element of Java. Basically, an enum is a special kind of class. We'll see what that is. How to define a class that has an array instance variable and how the correct or appropriate getter method is written for that so that encapsulation is not violated. And we're going to override one method, specifically the toString method, which is defined in the object superclass. The example we're going to use is the game from The Big Bang Theory that was invented by Sheldon called RockPaperScissors LizardSpock. And that was an extension to the RockPaperScissors game that we're all familiar with. And here are the rules for RockPaperScissors LizardSpock. We have, as is traditional, scissors cuts paper, paper covers rock, so paper wins against rock, but then rock crushes lizard. Lizard poisons Spock. Spock smashes scissors. The scissors decapitate the lizard eats the paper disproves Spock, and Spock vaporizes the rock, and, as it always has, rock crushes scissors. Again, this is from The Big Bang Theory. So we are going to implement that. The first thing is that since there are exactly 5 and only 5 possible hands that can be put forth, that makes it a natural for using an enum. Now here's what our enum is going to look like. We're going to call it the hand, because when you play the game, you put your hand out, and in the form of either the rock, which is a fist, the paper, which is an open hand, the scissors, which is 2 fingers, and the lizard is kind of a weird fist type of thing, and then Spock, of course, is the live long and prosper one. So our enum is going to have the 5 possible plays, the ways you can exert your hand. Our class, we're gonna call it Rock Paper Scissors Lizard Spock, and its simplified UML class diagram looks like this. We're going to have a single array of ints, which are going to be the wins, and the idea there is that the 0 array is going to be for player 0, and then player 1 will be tallied in the second second index, which is index 1. The methods that we're going to write are, well, the main one is this single play where we pass it 2 hands. The first argument is going to be for player 0, the second one for player 1. Then we're going to have a getter for the wins array. And then the winner, after a certain number of plays, is going to be the one whose wins are bigger. And there we'll either have player 0, player 1, and then if there's a tie, we're going to return something which is not one of those, say -1. Then, because there's a possibility of ties, we're going to have a method that says to get the number of wins. And then finally, the toString is going to be what is overridden. The toString method is defined in the object class, which is the superclass of all these ones. And to finally test it, we're going to, instantiate the Rock, Paper, Scissors, Lizard, Spock class, and we're going to invoke single play with every combination of the hands, and then verify that each combination produces the correct result. So let's get started. Okay, I'm going to put it in the class code so you'll be able to download it. And I am going to put it in a sub package. So just for brevity, I'll RP paper, scissors, lizards, RP SLS. That'll be the name of the package we put this in. All right, so the first thing we're going to do is we are going to create a class, actually not a class, we're going to create an enum. And so in my case, the enum comes up on my right-click menu, but that's only because I've done it before. If yours doesn't come up, then you need to go to Other, so we'll do that, check on Java, and then we have our various Java options, Java class interface. Here's an enum, and so select that. Remember, we called it hand. And then when we finish, we see that hand has been created. And notice instead of saying public class hand, it says public enum hand. Now the way to define an enum, at least the simplest possible way, is to simply just give it the names. And so the convention is that they're uppercase, and there's kind of a reason for that. So we'll follow that convention. So rock, paper, scissors, lizard, and Spock. And that's all it takes. So enums are very easy to create. And it turns out that they're very handy. They're much more type safe than just using magic numbers, magic integers. And notice how easy that was. Well, easy when you know how. Okay, so these are going to be the 5 possibilities. And so if I have a variable of type hand, the only possible values it can take are these 5, and null. It can be null. So that's something that we might want to watch out for, although in this one I'm not going to fuss too much about it, but just know that that could be a possibility. Okay, so we've created our enum. Now let's create our main class, or not the main class, but the class for the game. And we're going to call it rock, paper, scissors, lizard, Spock. And we finish, and there's our class. Now, the way I like to define classes is I start with the instance variables, and then I write whatever getter methods or setter methods are involved with that. Then the constructor. So here, actually, if you remember, wins was our instance variable. And to remember, one of the things that we want for it is get wins, the getter method for that. So let's go and create that using our friend refactor. So we say refactor, encapsulate fields, and I don't want the setter, I only want the getter. The visibility is private, the accessor visibility is public, and we will refactor it. Now, NetBeans is kind of snarky about this. It likes to put it up here. I don't like it there. So what I'm going to do is just simply move my instance variable up to the top because I like it down there. Now, here's the problem, is that simply returning a reference to our instance variable will break encapsulation. That is, that'll allow someone who has a reference to this instance of this class. If they invoke getWins, they actually get the no kidding array, and we don't want to allow that. And so whenever you have an array that's an instance variable and you want to write a getter, and this applies to setters as well, you always want to clone it. Now the next thing on this is the constructor. Now in this case, there really isn't anything that we're going to that we need to pass into the constructor, but we typically do want to instantiate our instance variable. Oops. Okay, so remember the wins are going to the win 0 is going to be for player 0. Wins 1 is going to be the number of wins for player 1. And I want to make sure to instantiate it in the constructor. Now let's see what else we wanted to do. Oops, this is where I got the rules. Where is it? There. All right, so we have the getter for the wins. We want to get the winner. So let's, and then get number wins. Actually, that's the next easiest one to do. So let's do that. Again, the principle of laziness says that you always want to pick off the easy ones. Okay, so now how many wins are there? Well, the sum of the two. Okay, and this is a primitive, so we don't have to worry about breaking encapsulation. So we have that, and then get winner. Okay, that's a little bit trickier. So let's do that. Now the winner is going to be the one whose wins are greater. And how are we going to determine that? Well, let's use, this is where an if statement is going to be handy. There are a number of different ways of doing this, but so let's say that if wins 0 is bigger than wins 1, we'll return 0. Else, if wins 0 is less than wins 1, we'll return 1. Okay, and what if they're equal? Else, return -1. So the winner is going to be nobody in that case. Now this is a first cut at that. Now and for a small method like this, that's really not such a big deal. But this does have one questionable design, and that is I have multiple return statements within a single method, and that's generally not advisable. So in a case like this, it's best to essentially redo the method like this. So I'm going to declare my winner to be -1, and here I'm going to set winner equal to 0, 0, if the wins are greater here, else winner is going to be 1. And now I actually don't even need this final else because I've initialized it to what the default is. So if wins 0 and wins 1 are exactly equal, then neither one of these if statements will be true, and so it'll simply return this. And this has, well, notice it has less code. That in itself isn't such a benefit, but it has one and only one return statement. Just in general, it is better style to have a single return statement at the very end rather than having multiple ones throughout, as it did there. Okay, so now we have, well, I'm going to defer this single play, and now I'm going to jump to overriding the toString method. So now here's the thing, and let me illustrate this by just sort of having our little test method. So we can actually write a test method before okay, and that again, that's going to be a main method. Should be a main method, yes. All right, so here's, well, I'll just call it a game, and we instantiate our game like that. And when we try to print it, here's what we're going to see. What we're going to see is the name of our class, so the fully qualified name. So we have the package, and the package consists of this string right here, the name of the class, and some gobbledygook. That gobbledygook relates to something called a hash code, but that's not very informative. If we want to know, what is it we want to know about this? Well, really the main thing is who has more wins. Now to do that, what we do is we write a toString method. And it has to be exactly this form. Again, oops. So there it is. Okay, so it has to return string, say toString, and have absolutely empty arguments. All right, so what can we do with that? Okay. Okay. What I want to know is who has more wins. Now there are nicer ways of doing this, but again, we're just kind of getting it done. Oops. Oh, player. There we go. Now notice that NetBeans suggested this override. So this little @ see this little @ override? Again, we'll talk a little bit more about what that is. That's actually not required, but it's just an indication that we have overridden a method. And now when we go to do what we had before, which is just to print this out, notice that now we see that player 0 has 0 wins and player 1 also has 0 wins. You know, why? Okay, pop quiz, why? Remember, when we instantiate an array, the contents of that array are the default value for that array. And the default value for ints is 0, and we haven't done anything to change that. Notice we've never assigned the wins to anything else. And now it's time to, oops. Why do you keep doing that to me? Okay. Single play hand-hand. And that's going to illustrate how we do, where are we here? And I just want to, okay, so it was a void, so we'll give it a void. Now, what did I call it again? Single play. Okay, so the idea is that each single play, player 1 is going to have something that goes in, player 2 is going to have something that goes in. And now we need to look at what these rules are again. And this is where we need, well, there are a number of different ways to do it. The way I'm going to do it is going to be with nested switch statements. The alternative are a bunch of if statements. I'll leave it as an exercise for the interested reader to look at that. So now, up until a few versions of Java ago, this actually wasn't possible, but now it is. So we can use, remember, we can use switch statements on ints, we can use them on strings, and we can use them on enums. Now, there are 5 cases. Okay, now notice, so these are the only 5 possible cases. I've listed them all just for completeness, and we always want to have a default, even though in this case nothing really can possibly go wrong. Okay, so this happened. Now we have covered all bases in terms of what player 1 can play, and now we got to consider what player 2 can play. So inside, okay, so let's say if player 1 chooses rock, let's do a switch on player 2. Okay? Now, we need to refer to the rules. Well, first of all, if player 1 plays rock and player 2 plays rock, then there's no winner, so we're just going to break. Now, rock crushes scissors and smashes lizard. So rock beats if there's a scissors, or if there's a lizard, oops. Okay, now what I've done here is, remember, if we don't say break, then it's going to fall through. So if player 1 plays rock and player 2 plays scissors or lizard, then player 1, or if player 0, I renamed these badly. Okay, instead of player 1 and player 2, they should be player 1 and player 0 and player 1. All right, so let's fix that. So let's change player 1. Again, select it. This is how you can change the names. So let's rename it to player 0. See, I'm coding this in real time and showing you all the mistakes that I make as well. So player 2, we've refactored, we're going to call it player 1. And there, just with a few little clicks, we have now gotten the names the way we want. So player 0, player 1. So if player 0 wins when he plays rock and player 2 plays scissors or lizard. Now, if the player 2 plays paper or Spock, remember Spock vaporizes the rock, then player 1 wins. Again, it's always a good idea, in this case, at least have a default in there to show that you haven't forgotten about it. And we need to do a similar thing. So I'm going to do one more. So if player 1 plays paper, we're going to switch on player 0 plays paper. We're going to switch on player 1. And a similar sort of thing. So if player 1 plays paper, then nothing happens. But paper covers rock, so it beats rock. And paper disproves Spock. So I'm not exactly sure what that means, but in either one of these cases, the first player, player 0, wins. And then finally, in paper, the lizard, let's see what, paper, scissors cuts paper, and lizard eats paper. And then, again, a default. We could put an error message there. Okay, I'm going to go away for a little bit and finish this up, and then when I come back, we'll write the test. I'm back, and I've finished implementing the Rock, Paper, Scissors, LizardSpock class, and now to take into account all of the different possibilities. And so now let's test it out. Remember, when we just printed the game, it should come out exactly the same as before because we haven't done anything yet. Now what I want to do to test it is I want to try every possible combination of the hands that can be played. Now to use that, I can exploit the fact that the Enum class that I've defined can give me an array of all the possible values by means which I will now show you. So let's first, so here's going to be the player 1, and there's a method called values, which is automatically defined by each enum, and that will give me all of the different values of the hand enum. And for the second player, I'll call it P1 in, again, hand values. Okay, so for each of those possible hands, I'm going to have a single play. So for what the first player played, what the second player played, and after each game, I'm going to just print out what happened in the game. And that's where writing that two-string for game was very convenient, because now after each play, well, actually I can show what happened, but I also need to say what was played. So let's I'm going to do it this way. So these are going to be the hands that were played, and the result is going to be this. Now remember, %s stands for a string. So what I want to do here is, this will say when player 0 plays this and player 1 plays that, then this was the result. All right, let's see what that does. Okay, so now we have all the different possibilities. So, and this was the initial one, so we'll just skip on that. So let's look right here. So first, rock, and we see that player 0 has 0 wins, player 1 has 0 wins. Again, that's good because rock ties. Now rock and paper, what do we expect? Paper covers rock, so player 1, the second player, whose index is 1, wins, and indeed, we see now player 0 has 0 wins, player 1 has 1 win. And for the same object, this is going to be cumulative. So for the next one, rock, scissors, so rock crushes scissors, or smashes scissors, and so now player 0 wins, and now it's 1-1. Rock and lizard, rock smashes lizard, so again, player 0 now has 2-1 wins. Spock vaporizes rock, and so now we're tied again, and we go through all of these different possibilities. But let's just make sure we check each one. So again, scissors, paper cuts scissors. Before that, we had 4-5. And so scissors should win, and now we have 5-5. Scissors is a tie, and so we're still at 5-5. Okay, scissors, lizard. Scissors decapitates lizard, so it's now 6-5. All right, let's look at lizard. Lizard, rock, so rock crushes lizard. And okay, so that's fine. Lizard eats paper. And now we see we have a problem. See, now look at this. Before we played lizard and paper, where lizard should win, we had 6 wins on player 0 and 7 wins for player 1. But then after they played this, notice that player 0 has 7 wins, which is correct, but player 1 has 8 wins. What the heck happened? Okay, everything was going fine up to there. Well, what happened was, and I confess I did this deliberately just to show, to illustrate some easy things that can go wrong. So let's look at how I implemented the case here. Again, in the outermost switch statement, we had player 0, and so rock, paper, scissors, and then, okay, so here's lizard. Here's the case where player 0 plays lizard. So now we switch on player 1. Okay, so lizard, tie, no problem. Okay, lizard eats paper and lizard poisons Spock, so we increment the wins here. But then look, I forgot the break. And again, that was part of the show, but this is what happens. If you forget the break, then what happened is it incremented wins for player 0, dropped down and also incremented wins for player 1. That's not what we want, so we want to make sure that we break on that. And this is also why you want to make sure that you always test everything, and because nothing can possibly go wrong. Okay, so now we want to make sure we haven't broken anything else. I don't think we have. Let's do a spot check. Paper and Spock. So before paper Spock, it was 3-4. Paper disproves Spock, and so now it's 4-4. Okay, that's fine. We can do all the other checks, but let's kind of come down here. So now lizard. Remember, rock smashes lizard. This is where things, I think, started to go south, or no, it was on the next one. So lizard eats paper, and now we go from 6 to 7, and 7 stays the same. And now scissors decapitates lizards, and now it's up to 8 there. Okay, so now our method is working correctly. Now the next thing, of course, is to make sure that it gets commented. I will do that at another time. But just to recap, we've defined an enum, and jumping ahead, we've actually exploited one of the nifty things about enums, in that this values method, which exists for every enum that we define, will return an array of that type. In fact, we can see that here. See, the values returns an array, in this case of hand. We defined a class that had an instance variable that was an array. We instantiated the array. And then for our getter method, we made sure to clone the array. Now, I haven't tested these methods yet. That would be the next step. Again, I will leave that for now, but that's something that should be done, because you should always test. Now here, the long pole here were these gigantic switch statements here. Is that the best design? Who knows? Your mileage may vary, as they say. There is probably a very clever way to do this, but this was a very straightforward way to do it. And what I like about the switch statements in this case is that it does make everything perfectly clear. In other words, when I switch on the first player, it says when the first player plays rock, these are all the things that can happen depending on what player 1 plays. And that's true for each one of these. And it may seem very verbose, but I promise you that if someone were to read this, they would be understanding exactly what the intent was. And if there was a mistake, it would be fairly easy to pick it up. The only tricky thing to not pick up would be the absence of a break statement where there should be. See, here I exploited the fact in this particular case that rock would beat both scissors and lizard, and so I combined the two case statements. So if when they play scissors, it'll fall through and execute this regardless. And if it's lizard, it would just fall through to that. Okay, that's all for now, and I will see you in the shed.